Right. So this presentation is a case study on public transport protection with water mist technology. I have a case study of a metro project in Budapest where the technology has been used a number of years, and I want to run through with you the background, why the customer has decided for water mist technology in comparison to other fire protection systems, and why water mist is such a good solution for this kind of environment. Now, if we look into urban mass transport, due to the growth of the mega cities we have throughout the world, and the related public transport has become more and more important and a challenge to move people from one place to the other. So more and more underground metro systems are built, or they have to refurbish or be extended in cities to make sure that people can quickly be transported for short distances at high frequency in the mornings to the work and in the evening back. So the capacity of these public transport systems is constantly increasing, and thus fire protection also gets more important in this field, because in case of a potential fire, people have to rapidly be evacuated of such an area, and this causes quite some challenges, particularly if the metro stations are quite deep and people have to move long distances to move out. So, and because if such metro station cannot operate in a proper way, many metropolitan areas, large cities, would have a problem and would collapse. And this is where fire protection is important. This has been seen also in real fires that already have happened in the past years. Mainly due to the excessive fire loads by the trains, the metro vehicles, which are going into a station, this causes quite a large risk for the passengers on board of the trains, but also people being on the platforms who have to rapidly move out of there, and which have to meet safe environments to be able to self-rescue themselves. In addition to the metro vehicles, there are also large amounts of electric equipment in such a station, and of course also the goods that people carry around and carry into the underground station, which represents a fire load. And in addition, these areas are quite strongly ventilated, which of course blows oxygen into a potential fire scenario and even increases potential fire, which is a real challenge. So the fires themselves, they are either caused by faulty equipment, which happens, but also by vandalism or by arson fires, which are set into the metro station. We have seen this in metro stations in Korea many years back. And also it happened in London, where quite a number of fatalities happen. So a lot of operators of a metro station, they look into possibilities how to best secure these stations and make sure that these areas can be evacuated in a short time. And the problem there is, of course, that in case of a fire, since the smoke cannot be easily extracted, that not only the heat is a challenge, but also the rapid smoke spread in the area. In addition, you have the behavior of people in congested area, panic can come up, and this makes it even more challenging for evacuation. In addition, the access for fire services, for the fire brigades into the area are difficult. So often it's delayed until they can really get down to the platforms, which causes an additional challenge. So looking at metro stations, it's important that we take a holistic approach to fire protection. To properly mitigate the risks that we have in the area, it's not only about one system, it's a combination of different measures. So water mist technology is seen very beneficial in this field because of its high cooling ability and also its partly washing ability of smoke. So this is a good thing, but of course the system has to work together with other safety means like the fire detection in such a field, like evacuation measures that are prepared, and only as a holistic approach this is properly working. What is key, of course, also is that the downtimes are reduced to a minimum. So for the operators of the metro station, in case of a fire, they want to come back to operation in as short time as possible. And this is again where water mist technology is seen beneficial because of its limited water usage and very effective cooling and fighting of the fire. So when it comes to the integration of the system into a particularly existing metro station, then also it's important that the system is small, that, for example, piping is easy to be retrofitted, but also water storage requirements are as small as possible. And again, there, water mist has its benefits. So coming to the Metro Budapest project as a case study, these metro lines in Budapest, they are quite old. The first metro line was opened in 1896, so belongs to one of the oldest lines throughout the world. At that time, this metro line transported 250,000 passengers per day, which of course today for a city like Budapest is not sufficient. So today a number of other metro lines have been added. So in 1970, the metro line M1 was refurbished, and at the same time metro line 2 and metro line 3 was opened to then connect also other parts of the city of Budapest. In 2014, metro line 4 was opened. This is a new built line in 2014. So in total today, Metro Budapest is operating 4 metro lines with around 40-kilometer underground transport network and 52 metro stations, which I will talk about in my presentation. And today it's about 1.3 million passengers which are frequented throughout the metro network, so substantially more than it was in the beginning. Now the operator of the metro, BKV, for them, it would be a disaster if they would have traffic discontinuance due to a fire situation. So they, around the year 2000, they looked into measures that could be taken. They did a risk assessment and how to mitigate the risk of a potential fire into the metro lines, particularly because they are operating quite old vehicles, like you see here on the pictures, which were built around in the 70s. So they represent a far higher fire risk than modern vehicles that you would see in modern metro lines. So a risk assessment was carried out as a holistic approach in this case, where not only firefighting systems were looked at, but fire detection also would look at, the access possibility of the fire services, smoke extraction was part of it, but last not least, also the overall cost evaluation was key. So the life cycle cost evaluation was also a key factor, and this is where water mist was seen very beneficial. Why is water mist then a topic in this field compared to other technologies, particularly sprinklers were looked at here? because on the one hand, we could demonstrate the ability of water mist to effectively fight the fire. So there's a fire test proof by the fire test that we have conducted for all protection areas in the metro line. It has a very high cooling ability, as I was already mentioned, and using little amount of water, so the lowest damage potential and the shortest business interruption. So the lowest impact on electrical equipment as well. It has a potential to wash parts of the smoke, so there's a smoke reduction with the technology. And the interesting for the client was that with one technology, all areas that had to be protected could be protected at the same time, where other concepts often requested a combination of different systems, like a sprinkler system in combination with a gas extinguishing system. So this is where overall, when also the life cycle costs were evaluated, water mist had a very positive balance for that. Now, to get the system approved and certified for the project, all the fire test protocols had to be provided, the approvals had to be provided, but also in Budapest or in Hungary, a specific local system certification process had to be undergone. So this is where the Approval Institute, EMI, was involved, which cross-checked all of the tests that were conducted by other parties before, like VDS, or other parties, for the technology as well as for the fire performance in the field. A challenge has been the platform protection as such, because for that there is no fire protocol within the standards. So based on the European standard, there's a chapter there which describes how to develop a fire protocol with all involved parties. And this has been used as a basis to develop a specific fire test protocol for this risk area. Now, for all other areas, protocols existed. So for public spaces, for storage areas, you've seen that in my previous presentation. For transformers, these are available. For machinery spaces, for cable tunnels. This is where all material was available, both on the fire test side as well as on the component test side. But the challenge was the platform area. And this is where different fire test scenarios were defined based on the risk assessment that was conducted in the area. So it was allocated that the main fire risk on the vehicle is underneath the vehicle, these old Russian vehicles, because they have exposed machinery units there, exposed electrical cabinets, and they also have cable conduits running underneath the vehicle. And this is where a fire was most likely to occur. So this is where then a fire test protocol was developed for all these individual type of risks. So different scenarios were defined, and also the type of ventilation that you would have along the platform, which is up to 1.5 meters per second, was included into the test scenario to make sure that everything is tested under realistic conditions. Now, since the fire is underneath the vehicle, a special concept was developed with nozzles being positioned between the rails and spraying upwards to directly cover the risk area. And the acceptance criteria for this application field was defined based on a VDS protocol, a document, a standard, which defines tenable conditions for evacuation into such an environment. So this is where we had to demonstrate that we can limit the temperature at the platforms below 65 degrees centigrade. We had to demonstrate that the potential fire underneath the vehicle does not spread inside of the vehicle or to the platform area, that the smoke gas concentrations are limited at a survivable level. This refers to carbon monoxide, carbon dioxide, and some other smoke gases. And of course, also the visibility was analyzed to allow self-rescuing of the people and easier access of the fire brigade. So based on the results of these specific tests and the approved application fields, water mist system was first integrated in 9 underground metro stations in the line M2 from 2004 onwards. This was then extended to 10 further metro stations of line M4 from 2009 onwards. In this metro line, water mist has also been implemented into the control tower, which you see there on the left side in the center picture, and also to the train depot area where they are servicing the trains. These also has been protected with the same concept, with the nozzles being installed between the rails. And 10 further stations were already equipped along the metro M3 line, and 9 are currently being installed with water mist technology. So there's quite a network of water mist systems in Metro Budapest to protect all the areas. Now, how does the protection look actually? You see here photos from the installation in the platform area. As I was mentioning here, the main protection area is between the rails pointing upwards to fight a fire underneath a train. These nozzles that are installed there have special protection caps to make sure that they do not clog in the harsh environment of such a rail area. In addition, this automatic system has been combined with wall hydrants, wall cabinet systems, like you see on the right side on the lower pictures, where water mist guns are installed for manually tackling fires. And this is used by the fire services. Mainly, they are trained on these systems. And you see the concept is always the same on the metro lines M2 and M3. These are old metro lines where the system is a retrofit. On the metro line M4, it's a new build, but the application is exactly the same. What is also being protected in all the stations are control rooms. These include switchgear equipment. In the old metro lines M2 and M3, you see this is quite old equipment, Russian equipment, which is protected by water mist. In the new metro line M4, this is more like a IT environment with monitors and servers protected by the water mist system. Cable tunnels represent also a key risk into metro stations. They are running underneath the platforms and normally have connections to the platform. So a potential fire could spread to the platform or smoke could spread to the platform. That's why these areas need individual fire protection. And this is where water mist is a very good means to fight these. The system has been integrated in a way that it is allowed to install additional cable trays with additional cable material, so extension has been taken care of. Another important application field into the metro station to safely evacuate people are the escalators. In the old metro lines M2 and M3, these are almost machinery spaces, so old kind of Soviet escalators, wide open spaces. So this is where it's more a room protection that has been installed there. And of course, also along the escalators themselves in the metro line M4, these are modern escalators where within the enclosure, the water mist system has been integrated. And all these areas of protection, they are supplied by water from a centralized pump unit, which is installed in each and every station. This pump unit, in our case, it's a high pressure water mist system. We need 4 pumps of 120 liter to supply the largest area, so the platform area of each metro station. An additional pump has been installed as a redundancy concept. So if one module breaks, this will take over the function. The system is supplied by fresh water, by the fresh water main line via a tank. There's, of course, a filtration unit installed, in this case, an automatic reversible filter, which makes sure that we don't get any clogging into the system, that the system is operational all the time. And then the individual areas have a section valve, which are activated by the separate detection system and route water into the area where it's needed. So to summarize my presentation, water mist has been around since quite some time, since 2 decades, for protection of underground mass transport facilities, and a very positive experience has been made with the technology. The small water amount that is used for the system makes it easier to integrate the system, particularly as a retrofit system into existing stations. So the high cooling ability of the system makes sure that people can more easily be evacuated of the area, but also the fire services can more easily access the area. And by this, by the little water usage, also the operational interruptions are reduced to a minimal, so the stand down times are reduced to a minimum, and this overall leads into a positive life cycle balance for water mist technology. Thank you very much for your attention.